Hi everyone, and welcome back to Dr. Brown Codes. I'm your host, Nick Brown, and today we are going to go over connecting to databases in R and managing data within databases, including joining across different tables. So like my other sessions, we're going to do everything here from Posit Cloud. So I have open here a browser. I'm going to go to posit.cloud. And I've already logged in. You'll have to log in yourself, of course. But here I have my spaces for Dr. Brown Codes. I've already made a connection here to Dr. Brown Codes and opened up a space. You can see my earlier videos. If you need to know how to do that, I will put a link in the description here. But I'm going to click on Dr. Brown Codes. And if you have been following along, you might already have this open. It's going to take a second or two to open up. And when that happens, I'm going to go to GitHub. I'm going to download the newest data, the newest code that I have put here, and we will start following along. Okay, so just opened up this space. It took a couple seconds to do that. I'm here under Dr. Brown Codes, and you can see that I already have open the last one that I did, the last episode, number 4 here. So I'm going to close that out. We're going to Files, and I'm going to look for number 5, which is what we're doing today. It isn't here, so what I'm going to do is go over here to Git. I'm going to click on Git. I'm going to pull down, and you can see now that it has pulled down number 5, dbplyr and connecting to databases. So I'm going to click on this folder, and in here you're going to see one QMD document, one Quarto document that contains all our code. So I'm going to click on this. Let's see, I'm going to make this a little bit bigger to make it a little bit easier to see what's going on. And the first thing it's going to tell you here is when it opens this up, it recognizes that there is a package that is not installed. So what I'm just going to do is click on that install right now. We should see down here in the console, it's going to install the RSQLite database. And when that happens, everything looks good now. We have all the packages that we need for today. All right, so first of all, this is a little bit wrong. This should be number 5. dbplyr and connecting to databases is what we're going to be going over today. So yeah, in this episode, we're going to learn how to connect to a relational database in R. Explore all the tables inside of it and learn to join the data together. This is going to be very similar to what you need to do if you're connecting to your data in your laboratory information system. Things like HistoTrack or Matilda are all going to rely on relational databases for storing your data. I am not going to directly connect to my laboratory information system today. So what I have instead is this synthetic database here. You can actually see it if you go back out to Project and Data. You can see that this is a synthetic database I put together. I made it to look very much like a HistoTrack database would look. If anyone works with HistoTrack, you'll get an idea of how it works today. All right, let's scroll down a little bit here, and we're going to start by loading the packages we need. So for today, we're going to use the tidyverse, and if you've been following along with other things I do, you know that I'm really a fan of the tidyverse, and so we're going to load everything that we need to get the tidyverse working. And then there's 3 more things that we're going to have to work with today. The first one is DBI. That is a package that helps to connect to relational databases. The next one is dbplyr. This is actually part of the tidyverse, but it is a way to use things that we're used to using in the tidyverse and automatically translate them to SQL code, which is what we need to actually interface with the databases. And the last one is RSQLite. This is a driver that helps us connect to the database here that we're going to be working with today. All right, so if you don't have any of those installed, you can always uncomment something like this, but I've had it all installed, so all we need to do in this code chunk is to load them. So I'm going to go up here to this Run Current Chunk button. I'm going to click on that, and you can see now it has loaded all the things that we need here for today's session. All right, so we'll talk briefly about drivers. Essentially what happens is relational databases are very common, but there are lots of different kinds of relational databases, and each one tends to need their own driver. So if you have a Postgres driver, you might need something like this. If you have a BigQuery, you might need something like that. Most of the time what you're going to use is what's known as the ODBC driver. And that is a way to connect to a database on the computer you're working on and then use that driver. So for example, here I'm working on a Windows 11 machine here. If I type in ODBC, you can see this brings up the ODBC Data Source Administrator. And this is where I would go to actually make a connection to the database. So I'm working from home today, but if I was working on my my computer at work, you would see that I have a connection already made here to my HistoTrack database. I don't have anything like that here, and we're going to be using this synthetic database today just to play around with. But if you are interested in connecting to your own database for your own LIS, this is where you would be going and doing it. And of course, you would need to get some instructions from your IT department to figure out how to do that. All right, so I'm going to close this here. And we today are going to connect to this synthetic database that I have. And we're going to do it with a piece of code that looks like this. So down here in line 41, we can see that we are using this dbconnect function. And that is actually setting up the connection to us. And we're going to put it inside a new object called con for connection. And so when we do that, we're going to say, all right, we're setting up this dbconnect. The driver we're going to use is SQLite because the database we're connecting to is a SQLite database. The name of the database is here, and so basically saying it's looking in the data folder, and this is the name of our database. It's a single file. It's a nice way to learn how to use databases because everything's in a single file instead of being in a server somewhere else. And then the last thing that we're going to put here is this extended types equals true. That just makes sure that the dates in the database are going to work for us. All right, so if we run this now, we're going to go over here and run this chunk. What we see now, if we go to environment, we should see that we have this con here. This is a new object, and it's saying that it's connected to the SQLite database for us. Great, so we just set up a connection to our database. Now let's actually start playing around with our database and seeing how it would work. We're going to scroll down a little bit. I've given you here an example of how you would set up. This would be an example code to set up to a real HistoTrack database, for example, if you want to do something like that. We're not going to do that today, but you can see here this is kind of some example code that if you want to use this when you get back to your own lab, you can. Anyway, let's scroll down a little bit and look at the database we have set up here. So one of the first things that we want to do when we look at a database is like, what's in that database? Can we get some information about it? And one really nice function we can use is this db list tables. And it takes a single variable in there, con, and so when we do that, we can run this and we can see that there are 8 tables in here. Activation history, patient, patient case, related patient, sample, test detail, and transplant history. So databases, relational databases, are really best thought of as having a whole bunch of different tables inside of them. It's going to be very similar to an Excel spreadsheet, for example, where you will have lots of different tables or tabs that you can use. And so each one of these is like a different tab in an Excel. But so now we know that there's these 8 different tables in there. Let's take a look at one of them. All right, so if we scroll down here, our next line of code is going to be db list fields. This is another nice function, and it takes 2 arguments here. The first is con, saying, all right, which database do we want to look in? And of course, we want to look in con, which is the setup, the database we already set up. And then we're saying we want to look at what the patient table looks like. All right, if we do that, all right, now it's printing out all this stuff here. So this is saying there are lots of different fields, or another way that these are commonly referred to are columns. Lots of columns in here. We can see that we have a column called patient ID, another one called UNIS ID, another one called hospital ID, blah, 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 blah. All right, that's a whole lot, and it's not really very useful for us. One of the really nice things that you can do here in R is instead you can make one of those tables look almost identical to a tibble, which is what we're used to working with in R. And we do that with this really nice function TBL for table, right? And so what we're doing here in this line of code, line 83 now, is we are going to use this table function to set up the patient file here, and we're going to assign it to patient table because it just gives us the ability to work with this a little bit further. So let's do that. If we run this line of code here, now look at that. Now this looks like an actual tibble, like things that we are used to looking in R. And in fact, there's some cool stuff going on here. At the top here, you can say that, well, the source of this table is the patient table within the database here, right? So, all right, this is already telling us that what we're looking at here is not actually in R yet. This is in the SQL database that we're looking at. But you can see here now all of these columns start to make sense. We have the patient ID column here, and you can see we have numbers below that. We have the UNIS ID table here, and you can see these look a lot like UNIS IDs. We have hospital ID. These look like medical record numbers. First, last name. This starts to make a lot more sense to us when we look at it this way. And in fact, this works very similar to a tibble where we can scroll through and we can see all the rest of them. Already I can jump out here and say these look like HLA typings here. A1CD, that probably means the code for A1, the code for A2, so the first allele for A, the second allele for A, and these look like serologic typings. We can scroll through here and we can see more. This now looks maybe like it's molecular typing. That's probably what the M means here. And we can see that we have two-field molecular typing. All right, anyway, so this is a really great way. Whenever I'm going and working on a database, this is the first and best way to get an idea for what is in that database. You know, right? You can look at each table and you can really get a nice idea of what kind of data is in there. All right, so one of the things that we can kind of do for fun is we can show what R is actually doing when it's talking to the database here. So one of the things I might have mentioned is that to talk to databases, you have to use a different computer code. And that computer language is known as SQL or SQL. And so if we take this patient table and we use the show query, and we run this here, we can see this is the actual SQL code, the SQL code here. And so when we want to just look at things, R is saying it is translating and it's using this SQL code, select asterisk from patient. This doesn't make a whole lot of sense to us if we know anything about R, but that's really the beauty of this because we don't need to know anything about SQL code because R is already automatically making that code for us, and so we don't even need to know about it. But anytime something's not quite making sense, you can always go to the show query, look at what the actual SQL code is, and maybe show it to somebody who knows SQL, it's not me, but can figure out what is going on. All right, let's move on a little bit here. The next thing we're going to do here is work on a couple more dbplyr verbs. And so these are going to be the functions that we're used to using already in R, and we can use them directly on our databases here. So for example, before I've shown the count function in R, and this is just a really nice way to get an idea about all the different values that are in a specific column. So let's use it here. We're going to take that patient table, which as a reminder is this table in our SQL database, and we're going to say, all right, we want to look at all the values for this column A2CD. When we do that, we can see now there are 15 different values here in this table, in this column of the table. There's 7 NA values. There's one that appears to just be missing. And then we have 4 that has 11, 3 that has 2, 7 has 24. And this all makes a lot of sense to us. This looks like serologic typing for A, right? You can also see that probably the reason why A2 is not the most common here is because this is the second of 2 alleles that would be for A, and probably A2 is going to be much more frequent if we were to look at A1. In fact, we can even do that. Let's just change this out to A1CD. run that, and we can see now that sure enough, A2 is the most frequent one there. 18 times there's A2, and nothing else kind of gets close. So this all makes sense to us, what we would expect to find in a table that contained HLA typing, right? And this was really great because we didn't even need to know the SQL code for this. We can just directly use this count on it, and it works like we think it should. But if we want to see exactly what it was doing there, we can just append this show query to the end here. If we run that, we can see this is the actual SQL code it's telling us. And sure enough, this does not look nearly as intuitive as our code does. All right, the SQL code was select A2CD, comma, count asterisk as n from patient group by A2CD. It would take me a long time to figure out that's what I had to do if I was writing SQL code, but luckily we don't have to because we can just use count there, and dbplyr is automatically translating it to SQL for us. So very, very cool. All right, let's scroll down a little bit more. We're going to try for a couple more functions in dbplyr, in dplyr. All right, so one of the things we can do here is the filter function. So what we're trying to do here is we're taking the patient table, then we're going to filter that table for hospital ID values, for hospital ID values that equal this MRN. All right, so if we do that, now you can see that we've gotten down to a single patient's file, basically. This patient name, Aram El Salim. All right, that's great. So we can see that we are able to filter what we're used to doing in R, and we get down to a single patient. All right, what else can we do? Let's scroll down here. Now we're down at line 121 here. Also, we can use the select, right? So one of the things here is you can see here up here it's saying, well, it's not sure how many rows are in here, but there are 53 columns. In fact, if we scroll through all of this, there's a lot of columns to get through. One of the cool things that we can do is we can select only the columns that we're interested in. So let's take this same patient table, then we're going to select these 4 columns: patient ID, first and last name, and category CD. And then we are going to arrange by last name. Let's see what happens when we run this. All right, if we run this now, it looks like we have 63 rows, and it has taken all of the patients that are in here, and it has arranged them by last name. So you can see A's at the top, and then B, and then C, for example. All right, so this is really nice. We've taken this really huge database that had lots of columns in it. We've gotten down to only the columns we're interested in, and then we even arranged them in alphabetical order. So lots of really cool stuff that we can do here. We can even ask some interesting questions like, all right, if we scroll down to 127 here, we can ask the question, how many types of transplants are in the patient table? All right, so that's great. We can take a patient table, then count category code, and then we're going to sort by true here. If we do that, we can see that it is taking the category code, and you can see that it's showing us all the different types of transplants that are in this particular code. And we told it to sort them, so it's already automatically showing the most frequent on the top and the less frequent on the bottom. So we can see in our database here we have 53 different kidney transplants, 6 lungs, 3 hearts, and 1 KP transplant. All right, very, very cool. Let's scroll down a little bit more. All right, everything that we've done so far has really been happening inside of the database. We have basically been telling our database to do some calculations for us and then give us back the results of that. But we haven't actually gotten any of that data into R yet. So if I can pause for a brief second here, one of the ways that I like to think about databases and relational databases is they are kind of like ordering data from a factory or from a catalog, maybe even better. Right? So there is some company out there that has your data, and you're looking through this catalog and want to know the kind of data you order. Once you've figured out what to order, you're going to call the company up and they're going to ship the data to you. So that is exactly what we're going to do now. We have figured out what kind of data is in that database. We know what we want, and we are going to order that data so it is physically shipped, and it's now going to be in our R session instead of being just in the database there. And we do that with this function called collect. Once we have figured out the kind of data we want, we can say, all right, collect all that data, and it's actually going to send the data to us in our R session. All right, so let's run through this line of code here. So we're going to make a new object that we're going to call OnePatient. And in that, we're going to take the patient table, that's our data from our database, right? We're going to filter on this specific MRN. Then we're going to select all of these columns that we're interested in. And then finally, we're going to collect that and have it sent to R. All right, so if we hit run on this, you can see now that this is going to look different. If we scroll up here, we can see everything we've been doing. It says the source is SQL and where that database is. Now, if we come down here, you can see it looks completely different up here. It's just saying atypical. That's because now the data finally exists in R. It is here in our computer, and it's no longer just on the database. And you can see it has everything that we asked it to do, right? So it filtered for that one patient. It gave us the patient ID, the name of the patient, and the typing at the A and the B locus for us. All right, very, very cool. The thing that we can do now when all the data is here with us is that we can start doing whatever else we want. All the things that we could do in R, when the data is actually back in R, we can analyze it however we want to. All right. Next thing that we're going to work on spend some time on is working how to join data between different databases. Between different tables within the same database. And we're going to do that, before we do that, we're going to make connections to every single table that is in our database here. So if we went all the way back up, you remember that there was 8 different tables within our database. And so this line of code is just making a brand new name, right? Patient table is for the patient case table for patient case, etc. So if we run this, we're not going to see any output here, but now we have made connections. In fact, if we go over here to our environment, we can see that we have connections for each one of these tables over here. Great. Now we can actually really start using these, and we can start learning about joining data between these different tables here. All right. Whenever we are working with a new database, I always find it's most helpful to look at the tables to figure out the structure of them and what kind of data is in there. All right, so that's what we're going to do in the next one, this next line of code here. So to do that in our studio here, all we need to do is put the name of the table within parentheses here. So if we do that for each one, you can see that it has opened 8 separate tables for us. The first one is the patient table. We've already spent some time working on that. The next one here is going to be the patient case table. All right, patient case table, we can see we have case ID, patient ID. Wait, that's interesting. If we go back to the patient table, you can see the first column there was patient ID. And now in this table, it also has patient ID. That is intentional. That is the way that relational databases work, because it's saying now this is the connection. This column is the way that we are going to connect data from the patient table to the patient case table. And in fact, we can probably go through the other ones here, right? We're at the related patient table. This also has patient ID, so this is a way to join those two tables. We can look at sample table here. This also has the patient ID. So we can see there are ways now that we can connect all these different tables back to our patient table, which really is the main table that we will be using in a LIS like HistoTrack. All right, very cool. So now that we know that there are ways to join the data between these different tables, let's actually practice doing it. All right, so let's try with a really simple join. We're going to start by filtering on one patient and then figure out what we can join that patient's results to. All right, so we're going to filter for this patient, Aaron L. Salim, and we're going to do that by taking the patient table, then filtering for this medical record number. All right, if we do that, we can see that this is something like we had before, Aaron L. Salim, and this is his information down here. And we have stored this in a new object called a.salim. All right, great. So now what we want to do is we want to figure out all of the samples that are in the database for this specific patient. And we're going to do that by taking this table that we just made up here, and we're going to do what's called a left join. And I'll pause here just to explain what that means. So when we think about joining, we think about tables that are on the left and tables that are on the right. Of course, you probably look at me, so it might be different. But the idea is that we can think of the first table that we get is the left table, and the second table in our line of code is going to be the right table. And a left join means the left table is going to be the main table that we keep, and we want to join anything from the other table directly to that one. All right, so what we're saying here is we're taking that table that we already set up that we called a salim, and then we're going to left join it to the sample table. And then how are we going to join it? And we've already shown up here that this patient ID is common between those two, so that's the way we're going to join it. So what we're saying, all right, left join, and this left join function takes two arguments. It takes what you're going to join it to, and then how you're going to join it. And so we're saying here we're going to join by patient ID. So that patient ID is the column that we're going to join by. So when we run that, now look at this. This was really cool. We started here with a patient that had one row, right? And we joined it to the sample table, and now we end up with 32 rows. And this is interesting, right? Because we can see now that every single one of these rows here looks like it has exactly the same information on it. But that's because whenever we're joining tables, it is duplicating everything that was in the left-hand table and just bringing in extra things that were in the right table. So if we scroll through this table now, we can see this is all duplicated, all duplicated, all duplicated, all duplicated, until we get down here. This is the brand new information. All right, so sample ID. Now you can see that there's different samples here. Every sample number is different here. This represents all of the samples that were in this sample table that related to this specific patient that we're working on. And so that's really cool, right? So we have figured out that for this particular patient, they have 32 different samples in the table there. And you can also see why we, in a relational database, we don't store everything all in one table. Because if we did, we would be duplicating this data every single time we got a new sample in. But instead, we have one table that just stores demographic information like the patient's name, medical record number, their genotyping, and we don't have to copy that every single time we get a new sample in for this patient. All right, very, very cool. All right, let's now go a little bit further. We have this new table here that we made, a salim samples. So this contains all the samples for this one particular patient. Let's now figure out every test that was ordered on any of those samples for that patient. So we can do that again by taking this, doing another left join, and this time we are joining to the test table. Now this is interesting because we're going to join this time by sample ID. Right, if we go back up here, we can scroll back through, and we can see that this sample ID is here in this table. And in fact, if we go back up here to the sample table, which was 4 tables down, we can see that this sample ID is also here. But what's really interesting, if we look here, sample ID has a uppercase I and an uppercase D. If we look down here, sample ID, never mind what, I'm sorry, I was on the wrong one there. I was actually looking for the test table. Let's go back up and do this one more time. Test table is one more down there. All right, test table also has sample ID here. But what you will notice is that here, sample ID, the I is in uppercase and the D is in lowercase. And this is kind of annoying, but you will find this happens all the time when you're working with relational databases. What this means is whoever was setting up this table, was ever setting up this database years ago when they did it, accidentally forgot to capitalize the D here, whereas they capitalized it in the other tables. And that's fine, as long as we know that. And this is something to know every time that you find something that's not quite joining the way you want to, you expect it to, go and take a closer look at things. But this join by function here makes it really easiest for us to say, all right, we are specifically saying that between these two tables, the sample ID in the first table and the sample ID with a lowercase d are exactly the same, and that's what we want to join. All right, so when we do that, we can see now that before we had 32 rows, meaning that there were 32 samples for that one patient here, and now we ended up with 182 rows. And that's because on those 32 samples, many of them got more than one test ordered on them. And so now we have 182 tests for those 32 samples for that one patient there. And so you can see that by joining data, we're starting to get more information on specific parts of the data that we're interested in. All right, really cool. Now, all of this, of course, has been happening within the database. If we wanted to collect all those, we could do something like this, where we're saying, all right, we're taking all the samples we're interested in. One of the things you might notice here is now this table is getting really wide, meaning that there's 75 different columns in here. And we might not be interested in every single column. So what we can do instead is we can take what we just came up with there. We can select for only the columns that we're interested in here, and then we can order that data from our data factory using the collect function. So if we do that, we can see now here, instead of having 75 columns, we only have 14 of them there. And these are the only columns that we're actually interested in. And great, so we have gotten information that we're interested in, we've downloaded it into R, and we can work with it that way. Very, very cool. All right, another kind of interesting thing that I wanted to show here is linking recipients back to their donors. All right, so we're gonna work in this line of code here, and you can see now this looks much more complicated. And the reason for that is the way HistoTrack works, and I have made this synthetic database to mirror or at least look very similar to the way HistoTrack is set up, is the way HistoTrack works is patients and donors are both stored in the patient table. So all the information that we want to know about donors is going to be in that patient table. There's not a separate donor table. However, we still want to know ways of knowing which donor is linked to which recipient in that table. And so to do that, we actually have to join to two separate tables. First, the patient case table, and then the related patient table. And that will give us information about which donors are are linked to that patient. And then we can finally use that information to join back to the patient table to figure out the donors there. All right, so let's work through this, and we'll read through our code to figure out what's going on. All right, so we're taking that patient table, then we're going to filter for that one patient that we've been working with. Then we're going to left join to the patient case table, and we're going to join by patient ID. All right, so that's the relation that we're going to use between those two tables. And then we're going to do another left join to the related patient table. This time we're going to join by the case ID, which is a different column there that we're going to join to. And that will give us information about the donors. And then we're finally going to join back to the patient table again. And this time we're going to join by the related patient ID, which we found in this related patient table. And we're going to match that back to the patient ID. All right, we're going to join back to this patient ID here. And interestingly, this is really something cool. When we join back to that patient table, we are basically taking the patient table, doing a couple joins, and then going back to the patient table. And when we do that, we're going to have a whole bunch of columns that has exactly the same name. For example, we're going to have a column named first name in the patient, and we're going to have a column named first name in the donor. If we put those back together, we're not going to have any way of knowing which one was from the recipient and which one's from the donor. So R has this really cool ability to use the suffix function where we can say, all right, well, we're starting with the recipient. So anytime we see two columns that have exactly the same name, we want you to put dot recipient on the recipient table, and we want you to put dot donor on the donor table, which will make it easier for us to figure out which data is coming from the recipient and which one's coming from the donor. All right, so then we're going to pass that onto another filter, and this is saying not is NA UNOS ID donor. This is basically saying we only want you to keep results that have a value in the UNOS ID donor, right? So we don't care about living donors, we don't care about anything except donors with a UNOS ID. All right, then we're going to pass it on to select, and we're only going to select some of the columns that we're interested in, and then finally we're going to collect that, meaning we're going to have it sent to R. All right, so this is a complicated line of code here, but we kind of went through. Let's see how this is going to work. All right, very cool. So we started with the patient ID. Now you can see we have hospital ID.recipient. So this is telling us very clearly this is a column that originally came from the recipient table. And if we go through here, we can see that we now have like UNOS ID.donor, and we can see here that there are 24 different donors for this particular patient. And we can see what the typing for each one of those donors was, right? So, here we had typing for the recipient. Here we have typing for the donor, and we have made it very explicit to us that this is from the donor, and the other parts, other columns are going to be from the recipients. All right, and this is really cool because now in one table we have, for example, recipient and donor typing. If we wanted to start calculating mismatches, we have all the data in the places that we would need to start doing that. So we've really, gotten everything set up so that we can analyze it and do something with it that's particularly relevant to us. All right, great. So that was a particularly big join, and you can see everything that we've been doing so far has been left joins. I do want to end with talking about a couple of different other types of joins that can be useful. I will say that the vast majority of the time, 90% of the time or more, you're going to be using left join. That's like the normal one you do. But there are other joins that can also be very useful for us. The first one I want to talk about is the inner join. And the idea there is if you're joining one table to another, if you do a left join, it's going to keep all the data on your left table and only join things from the right table that match that. An inner join is only going to keep things that are common between the two tables, right? So if you have 3 recipients over here and only 2 of those recipients had samples in the second table, it's only going to keep the 2 from the first table that had recipients there. All right, so let's do an example there. So we're going to take this patient table and we're going to do an inner join to the sample table. We're going to join by patient ID. When we do that, we can see we are left with 279 rows. So basically what that means is there's only 279 samples for all of the patients that were in there. And we can see that this first patient, Nanta Pop Su, has lots of samples, but if we scroll through, we can see lots of other patients had samples as well. But the idea for this inner join is we are, instead of keeping all of the data that was in our first table, we're only keeping the data that has a match in the second table there. All right, let's scroll down here and we're going to do another join. This one is the anti-join. And this is going to only keep rows on the left table that does not have a match in the right. And this is really useful if we want to find, for example, patients without samples, right? And so what we're going to do here is we're going to take that patient table and we're going to do an anti-join to the samples table. And again, we're going to join by patient ID. When we do that here, we can see that now it's showing us 0 rows. What does that mean? That means that for all of our patients, every single one had at least 1 sample on it. And that's really cool, right? And if we were just to change this to a left join and do the same thing there, we can see now that we had 279 patients there, right? But if we do this anti-join, this is just a really nice and quick way of saying every single one of our patients has a sample in the sample table. All right, really cool. The last one I wanted to show you is the semi-join. And the semi-join is much like inner join, but it doesn't add the right-hand columns, and this is useful for filtering without making your table actually wider. So let's do the same thing here. We're going to take the patient table, we're going to semi-join now to the sample table, and we're going to join by patient ID. When we do it that way, we can see, all right, great. These are all of the patients that do not have a sample in there. And this time it's showing us 63 patients there. All right, so again, don't spend too much time worrying about these different types of joins, the anti-join, the semi-join. Those are not used nearly as frequently, but if we have an understanding of how left joins work, that's really going to help us quite a bit. All right, so, each one of these has a SQL translation just like left join does. If we want to show query for anyone, we can always do that. So we can go up here and we can always just do Control-Shift-M, put show query in there. And we can see that this is actually what the SQL code is looking like for that. Again, we don't need to understand how SQL code works, but sometimes it can be useful to take a look at the SQL code. All right, the last thing is whenever you're working on a database, when you're done with it, it's always good to disconnect from that database, because a database is basically like calling up the company on the phone, and you don't want to keep that phone call going forever. So db disconnect is just a way to disconnect from here. So we see con in here. If we hit this, I don't quite know why it goes away. It doesn't go away, but essentially we have now closed that connection there. All right, cool. So just to recap some of the things that we've done here. So in this session, we talked about using DBI package plus a driver. And what we did here was an RSQLite to open a connection to a database with this dbconnect function. We explored our database with things like dblist tables, dblist fields. We made references to them with the table function, and that allowed us to actually scroll through and look at the table structure just as if it was in R. And we talked about how we can use show query to actually take a look at the SQL code that is being made from there. We ran a bunch of familiar different dbplyr verbs like count, filter, select, arrange, group by, summarize. We could pass those on and use it directly on our database. We showed how we can pull the results into R with this collect function. And then finally, we played around with joining some tables with the left join and the join by for columns that had the same names and contained those links between the tables. And then finally, we did a really quick look at some of the other join functions like inner join, anti-join, and semi-join, which are certainly used less frequently, but are still good to know about. All right, so these are really great skills that are going to be a lot of help to you whenever you're working on databases. And I wanted to stop the session by using some exercises here. So I have 4 exercises, and I will pause here, and I'm going to let everyone, I'm going to let you work on these exercises, and then we'll come back and I will show how we work on them together. And if you need to know, the solutions are all down here. All right, so let's stop here for a second, and then we'll come back in a moment, and I will work through these exercises. All right, so hopefully everyone had a chance to do their exercises. Let's go through these together and see how they are going to be done. All right, so exercise 1 here. It says reopen the connection. We disconnected it above. All right, let's start with that. So reopening the connection, what I'm going to do is scroll back up here to the top and find out when we open the connection. And this looks like it right here. All right, so I'm just going to copy this, paste it down into here, exercise 1, boink. Going to run this. All right, I've got a connection. I should see in my environment, I got that connection there. Okay. And it says, then use the count on sample table. All right, the next thing I want to do is I want to make sure that I can see all of my tables. So I'm going to go back up here to where I made connections to all of the tables. Copy that. Put it down here at this part. If I do that, all right, now I have connections to everything, and now I'm actually going to look at what it's telling me. All right, use count on the sample table. All right, so what I'm going to do here is I'm just going to break down here. I'm going to make new parentheses. I'm going to put my sample table in there. What I like to do whenever I'm looking at something is just start by looking at it. Before I do anything, before I write code, just look at it. All right, so I have sample table in here. I put it in parentheses that will automatically print out this nice table below, and I can see what's in the sample table. Not a lot of columns here. In fact, there's only 8 columns. We can see it all nice and clearly. All right, it says use count on the sample table to find out how many of each specimen type code value appear in the database. All right, so here after sample table, I'm going to hit Control-Shift-M to introduce a pipe, and then it's telling me to do count. So I'll type count, enter, and then I'm going to count specimen type code. I'm just going to copy that right down in here. If I run this chunk now, I should see that it made this table for me. All right, and so you can see here that there are 5 different values in specimen type code. The most common by far is serum, and then we have virtual, blood, ORDD spec, and plasma. All right, great. So we got the first one done. It required us opening up connections to things and taking a look. Let's move on to exercise 2. Exercise 2, for patient with hospital ID of this, find all rows in the transplant history table. Hint, join patient table to transplant history table by patient ID. All right. So just like I did last time, I'm going to open parentheses and I'm going to look at the patient table. Do that here, run that. All right, so this is the patient table. I'm saying hit join the patient table to transplant history table by patient ID. Well, so I mean, we can also do the same thing looking at the transplant history table. So copy, paste into there, run that. When we do that, now we can see what the transplant history table is, and we can clearly see here, transplant history table has patient ID, patient table has patient ID. So it looks like we should be able to join there. So what I can do is I can take this patient table, Control-Shift-M, then, and I'm just going to make this look a little bit prettier here when we're doing this. We're going to do left join, enter, and we want to join to the transplant history table, so I'll copy that into here, and then comma, space, join by, and we want to join by patient ID, and so I can just copy that here just to make sure it's going to work, put it straight in there. I do that, I have a nice line of code, patient table, then left join to the transplant history table, and join by patient ID. So if I do that, now we can see that we have a new table down here. Before we had the patient table that had 53 columns, and now we have 59 columns, and we had 7 columns here that we added to that, so that all looks like it matches up. We have 1 less column than if we were to put them together because the patient ID column was common between those 2 tables. But here now we have copied everything, and we can go and look through and see at the very end here, if we scroll over, we should see that we have notes, donor HLA-CD, donor ID, transplant date. These are things that were in this table and we're not normally with the patient table, but we've joined them together. All right, great. Let's move on to exercise 3. Use an anti-join to find out how many samples in the database have no tests associated with them. Remember, the column names are sample ID on the left side and sample ID with a little lowercase d on the right. All right, going back, use an anti-join to find how many samples in the database have no tests associated with them. All right, so it sounds like we probably want to look at the sample table first. So I'm scrolling back up here to that sample table. And the first thing I'm always going to do is just look at the tables I want to do. So put a parentheses in there, put sample table in. Boom, we're looking at the sample table. It only has 8 columns here. It's saying use an anti-join to find how many samples in the database have no tests associated with them. All right, that sounds like we want to look at the test table. So I can come back up here, I can look at the test table. I'm going to copy that down into here, take a look at the test table, hit run there, and now I can see at the test table, this has 16 columns here. But let's see, what is in common between the 2? We can see that sample ID is here and sample ID is there. All right, that's great. So we have the things that are in common, sample ID. And it's already even given us a hint here that sample ID here is with a lowercase d, and sample ID here is with a uppercase d. All right, so it's saying use an anti-join to find how many samples have no test associated with them. All right, so what I'm going to do here is I'm just going to take the sample table, copy, Control-Shift-M to get my pipe in there, just make this a little bit easier to look at, and then I'm going to do an anti-join. I'm going to anti-join to the test table, and I'm going to join by, and here we have sample ID on this table, sample ID equals, and in this one it is called sample ID there. Put that up there. If I do this, you can see that it shows me 5 samples here. So 5 samples that don't have any tests associated with them. And that's interesting. All right, cool. So we figured that out, that there's only 5 samples in this database that don't have any tests with them. And we use the anti-join here. And we even joined across a column that had slightly different column names, but it all worked out for us. All right, great. Let's move on to the last exercise here. All right, exercise 4. Write a query that returns for every row in patient table just the hospital ID, first name, last name, A1CD columns, but only for patients whose category CD is kidney. Pipe the result through short query to see the SQL dbplyr wrote, then collect it. All right, there's a lot going on here. Let's take this one step at a time. Like I said, the first thing I always want to do is look at the table to see what I'm doing. So I'm going to open up parentheses here, and it's saying start with the patient table. Fair enough. So I'm going to put patient table in there, run, and now I see what I'm doing. All right, what's the next thing it wants me to do? For every row in patient table, return just the hospital ID, first name, last name, anything. All right, so that is saying select. I know that very clearly. It's telling me to select. So I'm going to do Control-Shift-M to get my pipe in there, get an extra space, and I'm going to do select, enter. And now it's saying just keep the hospital ID. So I'm going to copy that into there, comma, space, first name. Now it's telling me first name, but the first name we can see here is actually spelled something different. And so we want to copy the thing that's actually in our table. Comma, space, last name. This is what the last name looks like here. And A1CD columns. All right, so we can go through here, A1CD, comma, do this. All right. So now we have subset this table with only these 4 columns, right? And we'll just double check that that's what we wanted. Hospital ID, first name, last name, and A1CD columns, but only for patients whose category CD is kidney. Oh, this is interesting. It's telling me to do something that I've already selected out. It's telling me that I need to filter on the category CD column, but there's no category CD column here anymore. All right, this is really interesting. So what I can do is I can comment out this line, and if I do that just by putting this hashtag, well, that's not going to work. So I'm going to have to put this in front. This is kind of an interesting thing to know about that you can comment out a full line of code like this, but if you're using a pipe like we do in the tidyverse, you have to do this at the beginning of the pipe. All right, so if we do that, now we can see patient table, then select. All right, now we have the full column here again because we've commented out this line. We're basically saying don't run that line of code. All right, now it's saying only for patients whose category CD is kidney. All right, so what we can do here is I'm going to hit enter again, Control-Shift-M, and I'm going to do a filter function, enter, and it's saying filter for patients whose category CD, and so we can look at that category CD. I'm going to copy that into here. Category CD equals is kidney. And I can just copy exactly what that kidney looks like in here to make sure that I get everything. I need to make sure I put that kidney in quotation marks because this is a character vector, and character vectors in R have to be in quotation marks. And so that's fine. So if I do that, now I'm going to run this line of code. And we can see now that category CD, every single one is kidney there, because that filter function worked the way we wanted it to. All right, in fact, now we can even turn on this line of code. And so now we have 2 lines of code here. And if we run that, we can see here that we have all of these, the columns that we wanted here. So we've done this. Let's just read through, make sure we're doing everything we're supposed to. Write a query that returns for every row in the patient table just these 4 columns, but only for patients whose category CD is kidney. That's what we did up in this line right here. Pipe the result through show query. All right, that's fine. We can do that. So enter, Control-Shift-N, show query. So if we run this now, we can see that we have exactly what we had before. The only difference is over here, it's actually showing us what the SQL code looks like. Interesting. And then collect it. All right, so the last thing we're going to do is collect. All right, when we do this, what we can see now is before we run this, we have this and it's saying that the source is this SQL table. If we run this now, we can see that now it's saying this is a tibble because it's collected the data and it's put it into R for us. And we can actually go there, select, and then we can see what the SQL code look like. That's fine. We don't need to know what SQL code looks like, but it's always nice to see it if we have it there. And we've done our last exercise. This is obviously much more complicated. We have 4 lines of code, and we had to make sure we did them in the right order and everything. All right, so it looks great. And then all solutions, if you want to take a look, we're down here. Thanks, everybody. This was a really nice way to show how we can use R to connect to databases and join data between different tables. And a lot of the things that you've learned here will be very useful if you're working with data in your laboratory information system that are stored in these sorts of relational databases. All right, happy coding, everybody, and I'll see you next time.